Okay, so I noticed that you guys have been really good at helping each other out when you have issues with your math problems on the ADN manual. It seems like anytime someone has an issue, someone has the answer and they're able to help you out. So my goal here is to kind of try and bring something else to the table instead of just repeating the same ADN manual questions over and over and over again. I know some of the teachers have given you some practice worksheets. I'm not sure if the one I'm about to go over is one of those. If it is, I'm sorry. I'm trying to bring up the resources I have at the last second here to kind of help you guys out, but you guys kind of seem to have it. But I just want to make sure I understand, you're not sure and you just want to get that 90% and, whatever. But, be aware of those tips that I said and you should be okay. If you did good on the practice test and all that stuff, you should be just fine. Just take a deep breath, read everything, think it through. Should be all right. But nonetheless, I'm just going to go ahead and do one of these worksheets that I have that's extra with the ADN manual in hopes to bring something new to the table and just to give you that extra practice, okay? So my first problem here, I kind of have it written up on the board. We have an order for drug X. The order is for 0.02 milligrams per kilogram per dose. What we currently have is 1 milliliter per 1 gram to 10,000 milliliters. Remember, when you see that ratio of 1 to 10,000, that means it's 1 gram per 10,000 milliliters. Okay, and what we currently want out of this equation is how many milliliters are we going to give to this patient, okay, of this medication. So how we're going to work this out is, again, we always start with what we have and what we want, okay? So what I have is 10,000 milliliters per 1 gram, okay? And I also want milliliters, so that's why I start out with on top. So now we need to find a way to cancel out these grams. I don't have any grams anywhere else in the equation, but I do have milligrams like I have underlined here, so we can kind of start with that. So I have 1 gram per 1,000 milligrams, right? And now I can take my 0.02 milligrams, and here I'm going to write my per kilogram per dose, because that's how the equation is written out here. This might confuse you a little bit. This is just how I do my math problems, so however it works for you, just stick with it. I don't want you to mess up your math because you're trying to do it my way or something. Okay? But as of now, I found a way to cancel out my grams. I found a way to cancel out my milligrams. Now I need to find a way to cancel out my kilograms. So I know that pounds and kilograms can cancel out. So I have 1 kilogram equals 2.2 pounds, right? And my patient is 10 pounds, okay, over 1 over patient over whatever. So we're going to start canceling things out. And I'm not that smart, so I'm going to go ahead and pull out my calculator. So I have my 10,000 milliliters times 0.02 times 10. That equals 2,000 over, I have my 1,000 times my 2.2 pounds. That equals 2,200. So if I take my 2,000 and I divide it by my 2,000 divided by my 2,200, that gives me an answer of 0.909 and so on and so forth. So how does this work? These are milliliters, right? What are our rounding rules? If it is if it is more than a milliliter, round to the tenths. If it's less than a milliliter, round to the hundredths, right? So we're pretty darn close to our 1 milliliter here, and that is what our answer would be, because this would turn into a 1 or whatever, right? Okay, pretty easy. The questions might look scary, but just use the knowledge you know, think about it logically, break it down. It really comes out smoothly in the end.